All right, before I go over it, I do want to go over one thing, because I've been grading homeworks and I want to give you some feedback so that this doesn't continue to happen. One, I said it from the very beginning, but when you submit homework from WebAssign, I have to see the whole box of results. If there's 13 questions, I need to see all 13 questions. The easiest way to do that is split your screen between two apps, and it will literally shrink that box down. If you don't want to do that, then you take a picture, you slide it over, you take a picture as many times as you need to so I see all 13 boxes. This is how I know what you guys need help with. So if it's missed, if 8 and 9 are the ones that are missed, I go to 8 and 9. If you have work and it's a format thing, no problem, okay? But if everybody is getting 8 and 9 wrong on the homework, that's the feedback for me. So you have to include all the pictures, okay? The other thing is that you should never submit without a WebAssign score. It has to go to WebAssign and it has to go to Notability. WebAssign is checking your answers for you. So you want to make sure that you're getting that feedback, okay? Those are how we're losing dumb points. And I don't want that to continue to happen. The other thing is, let's say you get like 3 homework assignments in a week. At the end of the week, I might choose to go back and change one of those to non-graded. It never means that homework is less important than anything else. It just means that by the end of the quarter, you don't need 80 homework assignments, okay? There was a lot of you that already got the 88 or 85 docked, okay? Instead of resubmitting and regrading, usually at the end of the quarter, I will drop your lowest homework grade. So if you got the 88 or you got the 85 because you did it wrong the first time, I don't want to regrade stuff. Ain't nobody got time for that. You will at the end of the quarter, I'll go back in and I'll drop your lowest homework grade, okay? Questions on homework, WebAssign, that kind of stuff. Okay. You need to, okay, yep. All right, so this is the transformation. So talk me through this. Number 1, what's the shape? Parabola. The parent function would be f of x equals x squared. And what's my shift? Up 3. Literally go up 3, go up and out 1, draw yourself your parabola. 2, what's my parent function? F of x equals square root x. It's that curve pointing to the right. The plus 1 underneath does what? Right 1. The minus 4? Down 4. Right 1, down 4. Draw your curve pointing to the right. Number 3, the parent function is absolute value of x. The plus 2 inside causes what? Left 2. The negative 3, down 3. Left 2, down 3. Absolute value. I don't know why I just pointed that down. It doesn't go down, upside down. There we go. Absolute value. If it was negative, it would go point down. All right, 4. Parent function, f of x equals x squared. The 1/2 does what? Vertical compression by a factor of 1/2. The minus 2, down 2. So I go down 2, and I go wider. Number 5, back to absolute value. The negative on the front. Good. Reflection across or over the x-axis. The minus 1 inside. Right 1. The plus 2. Up 2. So right 1, up 2. Plot your, and the 5. Vertical stretch by a factor of 5. So instead of going 1 and 1, we're going 5 and 1. And the last one, back to square roots. The negative inside does what? Across the y. So it's going to point it left. The plus 3, up 3. Up 3, points it left. Questions on any of those? So again, the ones that are on your test, and there's 2 like these on your test, they ask for the parent function. They ask for you to describe the shifts. Make sure you're using the appropriate language, okay? They ask you to graph it. Questions? All right. Last section that's covered on this test, which is again next Thursday, is 1.5. It is combining of functions. This is also something you did in Algebra 2 Honors, okay? So this should seem somewhat of a review. There are a couple things that are new in this section, okay? But overall, most of it is review. These are all the things we can do with two functions. We can add them. So if it says f plus g of x, that is the same thing as saying f of x plus g of x. We can find the difference of them, which is the same thing as saying f of x minus g of x. We can find their product, which is the same thing as saying f of x times g of x. We can find their quotient, which is the same thing as saying f of x over g of x. And this one would have a domain restriction because of the denominator. And then we can do a combined function. We tend to call this fog, mostly because somebody asked me one year, like 3 weeks in on something, what's fog? And I was like, oh Lord, you don't pay attention. But that's what it means. That open dot is different than a solid dot. That means take the g of x and plug it into the f of x. If it was the other way around, it would mean take the f of x and plug it into the g of x. So the one on the right goes into the one on the left. We're going to do this with actual expressions, which you did last year. We're going to do this with values, which you did last year. What you didn't do last year was graphs. We're going to add in here how you would read a graph and use it, okay? This is where we want to go to. All right, example 2. So notice it's got 4 parts. Find A, f plus g, B, f minus g, C, f times g, and D, f over g, and their domain. So the confusing part for a lot of people is the domain part, okay? If you are combining two functions in any of these 4 ways, it's different when we get to composite, like when we do f of g, it's different. But for these, f plus g, f minus g, or f times g, or f over g, you have to check the domain 2 ways. 1, from your initial functions. If there's a domain restriction in either of the initial functions, you have to carry that through. 2, after you do what you've done to it. So if I add them and it creates a new domain function, a domain restriction, I have to include it, okay? But also we check it from the original. So if I look at A, is there a domain restriction in either f of x or g of x? No, no variable in the denominator, no variable under square root, right? So I don't have to carry anything down. So I'm just going to go through each of them. F plus g is 2x plus 1 plus x squared. You could literally leave it like that. If you want to rearrange it so the x squared is first, that's fine too. Same answer. Now, is there a restriction or a domain restriction now that we've added them? No. So what's the domain on this function? All real numbers, negative infinity to positive infinity. Then we go to B, and B says subtract. So f minus g is 2x plus 1 minus x squared. Nope. If we could combine like terms, obviously we need to do that, but this one doesn't even have that yet. We said there was no original domain restriction. Is there a restriction now that I've subtracted them? No. So domain still remains negative infinity to positive infinity. Then I go to C, and C is multiply. F times g. 2x plus 1 times x squared. And this time I can simplify. I'm going to distribute, so I get 2x to the third plus x squared. There was nothing to carry down. Is there a restriction once I multiply them? Still no, right? So negative infinity to positive infinity is still my domain. And the last one is f over g. So 2x plus 1 goes in the top, x squared goes in the bottom. Can't simplify it. It's going to stay just like that. Is there a restriction with this one? Yeah, what is it? X cannot equal 0, right? because it's in the denominators. Or x squared cannot equal 0, which means x can't equal 0. So my domain this time is negative infinity to 0 and 0 to positive infinity. Questions on those? Okay, go to B. First thing I'm going to check for is a domain restriction on the originals. Is there a domain restriction on f of x? What is it? Has to be what? Good. So 4 minus x squared has to be greater than or equal to 0. If you remember that when you have an inequality and a quadratic, this is where we test points. So I solve it as though it's equal to 0, and then you got to plug in points from your number line to figure out which range works. Okay, sound familiar? So we're going to solve it as though it was equal to 0, which I can factor this, 2 plus x and 2 minus x. Split and solve, and I get x equals negative 2 and x equals positive 2. And then I would set up a number line and test points. It's in every other situation, so I literally can plug the easiest one in, which is 0, and see if it works. If I plug 0 into the inequality, I get 4 minus 0 is greater than or equal to 0, and is 4 greater than or equal to 0? Yes. So this interval is what my domain can be, which would be from negative 2 to positive 2. Now that's important because I'm going to carry that down. Every time I use f of x, I also have to use that. Questions on that one? Now go to g of x. Is there a restriction on g of x? Yes. Same thing, greater than or equal to 0, so x is greater than or equal to negative 1. So now anything that involves both of these has to meet both those restrictions, negative 1 to positive infinity. But it also might have another one. So I'm going to wait till after I actually do the composite and see if it's a new one, and then all three have to overlap, okay? But I'm going to start with the plus. So f plus g is square root of 4 minus x squared plus square root of 1 plus x. Can you add two square roots that are not the same? No. So it literally stays like that. Now, did I bring in any new restriction by adding them? No, okay? A new restriction might come from putting one of those in the denominator. That's what we're looking for. Right now, nothing changed, which means I have to say x has to be between negative 2 and positive 2 from the first restriction, and then greater than negative 1 on the second restriction, greater than or equal to. And I can only take the overlap, which is from negative 1 to positive 2. Now go to B. This time it's f minus g, and I get the square root of 4 minus x squared minus the square root of 1 plus x. Any new domain restriction brought in? Nope, so same answer. Negative 1 to positive 2. C, f times g. Square root of 4 minus x squared times square root of 1 plus x. Now, WebAssign will actually let you keep it like that, so would I. But just know if it's a standardized test, you can keep going with that because they're both square roots. You can multiply out what's underneath. I could put them both under the square root, and then I could FOIL them out. You do not need to FOIL them out. You can leave them like this, okay? But this is also an acceptable answer. Did I bring in any new restrictions? No. So my domain is the same, -1 to +2. And then the last one is F over G. So F goes in the top and G goes in the bottom. You do not need to rationalize this, okay? That would be fun. But did I bring in any new restrictions? What changed? There's a variable under the square root in the denominator. How does that change the domain that was already there? It's no longer greater than or equal to. What happens to my domain? The -1 gets the parentheses. That's the only difference. Questions? So sometimes I actually think on WebAssign it will just say like find this and then find the domain of F over G. It might only ask for it for one of them, okay? The rule still applies. If it's in the initial, it carries down. If it's new, once you put it in the composite function form, then you have to keep it too. Questions? That is only for plus, minus, multiply, and divide. The rule changes when you get into composite functions, which is this. Actually, not yet, because it doesn't talk about domain in this one. In a moment. Okay. Notice that I now have a value inside my parentheses, right? So on the A, it says F of G of -1 and B, G of F of 2. I could have also done this with F plus G of 2, something like that. And there's two ways to do it. The first is find the composite using your expressions. So I would actually take this and this, add them together, and then plug in 2. The second way is to separate it out and find F of 2 plus G of 2. I think that way is easier because you get rid of the variables from the get-go. But if you like the other way, then do it the other way, okay? So again, I could have either taken those expressions and added them together and then plugged in 2. Or I can keep them separate, plug in 2 to the F of X, plug in 2 to the G of X, and then add those values together to get one number at the end. These are composite functions. The order we do these is important. Again, I could do the same thing. I could take this and I could plug it into the X there and get 2 times 4 minus X squared minus 3. And I can simplify this, 8 minus 2x squared minus 3, or 5 minus 2x squared. So I took the G of X, I plugged it into the F of X, and then I simplified it. And then I can take and plug -1 in. 5 minus 2, -1 squared would be 5 minus 2 times 1, which is 3. And that's my end goal. The other way to do it, and the way you'll have to do it from a graph, is first find the inside parentheses. So first I'm going to find G of -1, which would be 4 minus -1 squared. 4 minus 1, which is 3. And then I have to take that value and plug it into into F, sorry. So I'd get 2 times 3 minus 3, 6 minus 3, which is 3. It is a complete coincidence that they are the same values from the first, like from F of -1, from G of -1, sorry, to F of that. It's totally coincidence. The fact that these are the same would always happen. Both those methods should give you the same answer. Again, I choose to go with the second one. I choose to plug, but it's totally personal preference. You could do whatever you want to do. But I tend to plug the value in right away. So if I do G of F of 2, which one is 2 going into? F. So F of 2 is first. 2 times 2 minus 3 is 4 minus 3, which is 1. And then I want to find G of 1, which is 4 minus 1 squared. And again, it's 3. Somehow we ended up with lots of 3s on this stuff. But Questions on those? All right. This one says find f of g and g of f. Find the domain of each function and of each composite. So we're going to do it step by step. One, find f of g. Which one do I plug into which one? G goes into f. So this is 1 over x plus 3. I'm going to do b and then we'll go back to the domains. B is g of f. So now which one goes into which? F goes into g. 1 over x plus 3. Now here's the rule on composite functions, domain. This asks you to find the domain of each function. So I'm still going to go here, find the domain. I'm still going to go here and find the domain. But if it had only asked you to find the domain of the composite, then both of them do not get carried down. Only the one you are plugging into the other one gets carried down. So only the letter on the right. If it's f of g and g has a restriction, then it gets carried down. If it's g of f and f has a restriction, it gets carried down, okay? Because think about what you would be doing value-wise. If I had a number there, I would plug it into the one on the right. That's the one I'm worried about a domain restriction. Then that value would get plugged into the left. So look at A. I need to check the domain of G. What's the domain of G? All real numbers. Then I need to check the domain of f of G. Is there a new restriction now that I've made it f of G? Yeah, what is it? X cannot equal -3 because the variable's in the denominator. So I have to make sure that both of these are met, which means it's -infinity to -3 union -3 to positive infinity. Go to B. Now I have to check F's domain first. Is there a domain restriction from F? Yes, what is it? X cannot equal 0 because the X is in the denominator. Then I check my combined function. Is there a new restriction? It's the same we already had. So my domain is -infinity to 0 and 0 to positive infinity. If there was an overlap, then I would make sure overlap on the number line. So domain of, what do I do first? F, -infinity to 0, 0 to positive infinity. Domain of G of F is the same. Questions on that? All right, now we're doing from a graph. So they're a little blurry, but you can kind of see those graphs. The one on the left is the f of x. The one on the right is the g of x. So if it says find f plus g of 3, I don't have an equation to plug these into, which means I have to separate it out. I have to find f of 3 and then g of 3 and then combine them together. So using the graph on the left, which is f, what is f of 3? What's the y that corresponds to? Now g is the one on the right. What is g of 3? 1. So my answer there's 3. Again, I don't know why there's so many 3s in today's notes, but it happened. B would be f of 2 over g of 2. What's f of 2? What's the y that corresponds to the left graph where x is 2? 0. It doesn't even matter what g of 2 is, but g of 2 is 2. So this is 0. I guess it would matter if they were both 0, then it'd be undefined. And then this is an open dot. So this is f of g of 2, which means I'm going to find f of g of 2. First thing I'm doing is finding g of 2. And g of 2 is what? 2. And then I'm going to find f of 2. And f of 2 is 0. And then g of f of 2 means I'm finding g of f of 2. F of 2 is 0. And g of 0 is 4. Questions? Yeah. For B on 2? So the first thing I did was f of 2. So on the f graph, I'm going to 2. And I'm getting the y there, which is 0. Then I'm finding g of that. And g of 0 is 4. So innermost parentheses or right to left on the open dot ones, on the composite functions. We're going to skip that last example. Don't worry about it. Okay, that's it. You've wrapped up the content. That's going to be on your test next Thursday. I'm actually going to publish your review, but we're going to work on it on Tuesday and Wednesday. I know some of you like to get ahead, okay? Don't then ask me for like 7 extra practice reviews. It's not going to happen, okay? But if you know you're going to be swamped Tuesday, Wednesday, and you just want to start to review, that's fine. If not, take a break. Do the 1-5 homework. That's due Tuesday, okay? But the review is not.